अस्सलाम वालेकुम फ्रेंड्स, कैसे आप सब लोग? आई होप आप सब लोग बिल्कुल ठीक होंगे। वेलकम टू वीलॉजी बात किया शो। कैसे हैं आप सब लोग? आई होप आप सब लोग बिल्कुल ठीक होंगे और स्टडी कर रहे होंगे वीयू में कर रहे होंगे। और मैं तो वीयू में कर रही हूँ, तो वही सब आपके साथ शेयर कर रही हूँ, तो मैं वीयू का ही नाम लूँगी, ठीक है। सो ऑल द बेस्ट टू ऑल ऑफ यू फॉर योर मिड्स, फॉर योर प्रैक्टिकल, फॉर योर क्विज असाइनमेंट, JDBs एंड ऑल दीज थिंग्स, ठीक है। और अगर आप लोग मेरे चैनल पर न्यू हैं तो मेरे चैनल को सब्सक्राइब कर दें, मेरी वीडियो को लाइक ज़रूर किया करें, और आप लोग व्यू करके जो है ना चले ना जाया करें, सब्सक्राइब लाजमी किया करें, क्योंकि आपके सब्सक्रिप्शन से हमें हौसला मिलता है। और इसके अलावा आप लोगों को भी अगली वीडियोस के नोटिफिकेशन आ जाते हैं, और अगली वीडियोस के नोटिफिकेशन देखकर उसे नज़रअंदाज ना कर दिया करें, उसको देखा भी करें, ठीक है। हो सकता है कि कुछ ना कुछ आप लोगों के लिए काम का हो, सही है। सो लेट्स कंटिन्यू आवर स्टडीज़। तो इस वीडियो में मैंने जो है वो अपने टॉपिक्स कंप्लीट करने हैं। रिमेनिंग 7 जो टॉपिक्स हैं मेरे, सही है। यहाँ पर इसका कोई खुला हुआ है, इसके लास्ट डेट कल तक है मेरे ख्याल में, या 1-2 दिन है। तो मैं इसकी अच्छे से तैयारी करके फिर इसका सिलेबस कवर है, उसके बाद इसके पास 2 स्टेप्स रहते हैं, वो भी तैयार करके तो फिर उसके बाद अटैम्प्ट करेंगे। मतलब कि 2-3 स्टेप्स हैं, MCQ वाला स्टेप और इसकी जो इसके हैंडआउट्स होते हैं उनको रीड करने वाला स्टेप, ठीक है। एक MCQs इसके जो मतलब 3 स्टेप रह गए, मतलब कि फर्स्ट स्टेप में अब एक स्टेप जो था 4th स्टेप में करती हूँ ना मैं क्विज। पहले सारा का सारा सिलेबस कर लिया, ठीक है, वो मैंने अपलोड कर दिया, वो आप लोग जाकर के मेरे चैनल पर देख सकते हैं। उसके अलावा इस क्विज का जो अगला स्टेप है वो ये होगा कि हम लोग हैंड आउट चेक करेंगे, और उसके बाद हम लोग जो है ना वो वाले MCQs करेंगे जो पोस्ट और प्री असेसमेंट में है, ठीक है। उसके बाद हम लोग जो है वो वाले MCQs करेंगे जो यूट्यूब पर मौजूद है। हमें यूट्यूब पर जिस भी वीडियो से हमें मिल जाएंगे तो वो हम उठाकर उनको लिख लेंगे अपनी कॉपी में, अपने नोट पैड्स में, जो भी आपके पास चीज़ है, डायरी है, नोट पैड्स है, या फिर स्टिकी नोट्स है, जो भी है। मेरे पास स्टिकी नोट्स है, मैं उसमें लिखती हूँ, तो ठीक है। तो फिर आई होप आप लोग को मेरे स्टेप्स समझ आ गए होंगे। तो आप लोग मेरे चैनल पर जाकर देख सकते हैं, मैंने यही सारे स्टेप्स फॉलो किए हुए हैं हर क्विज़ के लिए, ठीक है। और हर असाइनमेंट का नोटिफिकेशन मैं आप लोगों को बता देती हूँ जो आ जाता है, तो मैंने अनाउंसमेंट भी बता देती हूँ। तो आप लोगों ने अगर कोई नहीं देखी, कल ही में हमने जो है वो हिसाब लगाया था कि कितने टॉपिक्स हमारे वीक के करने वाले हैं, वो वाली वीडियो भी आपने नहीं देखी तो वो जा करके देख लें। तो आई होप आप लोगों को फ़ायदा ही होगा, नुकसान नहीं होने लगा, ठीक है। तो चलते हैं आगे। मैं ये इसकी तैयारी जो है बाद में करूँगी, ठीक है, क्योंकि इसके लिए मेरे पास 2 दिन बाकी हैं। तो मैं बाकी के इस हफ्ते के जो टॉपिक्स है ना वो कर रही थी, क्योंकि थर्सडे है मेरे ख्याल में, तो यस, आज थर्सडे है, तो इस हफ्ते के दिन बड़े कम रह गए हैं, तो मैं चाहती हूँ कि इस हफ्ते के टॉपिक्स कंप्लीट हो जाए, उसके बाद मैं करूँ बाकी का काम, ठीक है। तो टॉपिक नंबर 71 है, 70 तक हमने कर ली है, और अगर किसी ने नहीं देखा तो वो जाकर देख सकता है। टॉपिक नंबर 71 है सिमिलरिटीज एंड डिफरेंसेस इन सीक्वेंसेस, ठीक है। तो इसका क्विज ले लेते हैं, प्री असेसमेंट, ठीक है, और इसको स्टार्ट कर लेते हैं हम लोग यहाँ पर, जस्ट लाइक दिस। इससे पहले जो टॉपिक्स है वो तकरीबन सारे ही बहुत अच्छे और इजी टॉपिक्स हैं। तो एक न्यू टॉपिक हमने पढ़ा है प्रोटीन सीक्वेंसिंग वाला, वो बहुत अच्छा टॉपिक है, अच्छे से समझ आ गया, वो बहुत अच्छे से, वो मतलब आई मीन मेरा फेवरेट टॉपिक है वो। आप लोगों ने बताना आपका कौन सा फेवरेट टॉपिक है, ठीक है। कमेंट में मुझे बताइएगा कि आपको कौन सा फेवरेट टॉपिक है। सो ये ज़्यादा टाइम ले रहा, तो इसको कुछ और करना पड़ेगा इस तरह से, और इससे करते हैं। हाँ जी, तो जाहिर वाली बात है, जब हम अटैम्प्ट ही नहीं करेंगे तो ऐसे ही होगा। चलते हैं आगे। What is the role of the promoter region of union transcription to be a template for okay. Okay, so let's move ahead. हम लोग चलते अपनी वीडियो की तरफ, इसको सुन लेते हैं.
Dear students, in this video we're going to talk about the similarities and differences in the biological sequences. You already know that by comparing two sequences, you can arrive at the similarity between the two sequences or the differences between the two sequences. Also, such an exercise can help you understand the relationship between the sequences. Besides that, you can also look at the evolutionary relationship and the history by looking at the differences between sequences. So let's start by considering a protein sequence that is given here. Only a few amino acids are mentioned. Typically the proteins are very long, but this is just an example. So we have M, Q, E, A, L, F, E, that is about 7 amino acids. And now we're going to look at what similarity means precisely. So if you have another protein sequence, let's say M, Q, V, A, L, F, and E, then you can obviously say that in terms of similarity, these two sequences are 100% similar. However, it can be the case that you are trying to compare two sequences wherein there are differences in their amino acid or nucleotide. So let's consider that case. So for specific differences, if you have another protein sequence then you can argue that there is a difference between these two sequences in leucine and isoleucine. So by looking at specific differences, you can see how two sequences they differ from each other. So in this case, the similarity will obviously be less than 100. In terms of relationship, so if you want to see the relationship between two sequences, then you can consider again two very similar sequences, and the relationship is obvious that these two proteins or peptides are sourced from the same protein or species. More so, let's consider another situation where you have slight variation in the last two amino acids. Then, as you can see here, these two amino acids are different for both of the sequences. Then you can say that these two sequences are partially related or may be related because they do not have a complete alignment, or they are not totally similar. Next, you can look at the evolutionary history as well. So if you have another sequence then you can say that these two sequences are varying in one amino acid And if you have another sequence, then you can further say that these two sequences are different in two amino acids, and so on and so forth. So we can see that we can probably assume that this sequence has given rise to this sequence, and so on and so forth. So therefore evolution has taken place in this order, and probably the sequence that is here at the end is the most evolved sequence. In this way you can also look at the evolutionary history. Now I will like to introduce exact matching to you. So the exact matching idea is that two sequences, they are not only similar in terms of the amino acids or nucleotides in case of DNA and RNA, but that their order in which they are present in the sequence is exactly the same. So as I mentioned in the previous example, if you are going for exact matching by placing two sequences against each other, then they should have the exact same amino acids or nucleotides, plus they should exist in the same order. However, as we just saw, there can be cases when this is not going to happen. So in that case, you will need to accommodate the difference. That can be done by the inexact matching, and there are various options that you can use, such as the regular expressions, the signature sequences, and the prosite patterns database, which we'll discuss later in detail. So let's take a look at the prosite pattern. So in this case, this is a pattern that is given in the textbook, chapter 3, page 44. And the hyphens here, so let's start from the hyphens. The hyphens, they separate the elements of the pattern. So all the hyphens are essentially separating amino acids from each other. Next, the letters refer to the amino acids. For example, here, R, B, C, and next, X indicates any amino acid that may be from the 20 different amino acids, and the bracketed numbers, they denote the repeat length. As you can see here, this X can be repeated 9 times, so it means any amino acid occurring 9 times. However, there may be a situation where this repeat length is variable, so in that case the variation is represented like this. So any amino acid, that is X, may occur 72 times till 86 times. So that is how you represent the prosite pattern for MAP kinase protein. MAP kinase protein is a very important protein. It phosphorylates a lot of proteins and is responsible in the mitosis and apoptosis in the cellular behavior. So using such prosite patterns, you can talk about sequences that are there and represent them using prosite pattern. In conclusion, the exact matches allow you to compare two sequences exactly, while inexact matching allows you to compare rather stochastically between various sequences.
So फ्रेंड्स, हमारी वीडियो फाइनली कंप्लीट हो गई है, तो हम चलते हैं अपने रीडिंग की तरफ. So यहाँ पर सिर्फ प्रॉपर्टीज है. एवोल्यूशनरी हिस्ट्री। इसके बाद है जनाब प्रोटीन MQ VK LFT। ठीक है, तो सिमिलरिटी इसमें अगर कोई और प्रोटीन है इसके जैसे हो जाएगी तो वो इससे सिमिलर हो जाएगी। सिमिलर होने का मतलब है कि दोनों को सोर्स सेम होगी तो वो इनका रिलेशनशिप हो जाएगा। स्पेसिफिक डिफरेंस, अगर कोई भी प्रोटीन इससे हाफ मैच करती होगी तो उसमें एक वो डिफरेंस हो जाएगा कि हाफ मैच कर रही है, और हाफ मैच जो नहीं कर रही है वो उसका डिफरेंस होगा। उसके अलावा ये कि वो पार्शियल मैच कर रही है, उससे वो इसका रिलेशनशिप होगा। ठीक हो गया। इसके बाद हमारे पास आगे चलते हैं एग्जैक्ट मैचिंग। Not only should that two or more sequences being compared have the exact same number of each nucleotide for DNA or RNA or amino acid for proteins, but that they should be arranged in the exact same order. Accommodating differences in exact matching with the regular expression signature sequences proceed patterns database। ठीक है, इसके बाद है जनाब प्रोसेड सिमिलरिटीज एंड डिफरेंसेस इन सीक्वेंसेस। इसमें है प्रोसेड पैटर्न फॉर MAP काइनेज। ठीक है, मैप काइनेज, हाउ बोल्ड 3 पेज 44 चैप्टर 3 पेज 44। अच्छा ठीक है, ये रेफरेंस है। FX into 10 REX into 72 and 86 RDX KX9 और हाइफन के बाद में C हाइफन सेपरेट द एलिमेंट्स ऑफ द पैटर्न। ठीक है, उसके बाद लेटर्स रेफर टू अमीनो एसिड्स, X इंडिकेट्स एनी अमीनो एसिड और ब्रैकेट नंबर्स डिनोट द रिपीट लेंथ ऑफ अ रेसिड्यू। If this repeat length varies, the range of this variation is quoted in the brackets। ठीक है, इसके बाद इंट्रोडक्शन टू कंप्यूटेशनल बायोलॉजी an evolutionary approach by Bernhard Houbold, Thomas V. Mitogen activated protein kinases MAPK are for protein kinases that are specific to the amino acids serine 309 and tyrosine। MAPKs belong to the CMGC CDK MAPK GSK3 CLK kinase group। MAPKs are involved in directing cellular responses to a diverse array of stimuli such as mitogens, osmotic stress, heat shock and pro-inflammatory cytokines। ठीक है, they regulate cell functions including proliferation, gene expression, differentiation, mitosis, cell survival and apoptosis। ओके, आगे चलते हैं सिमिलरिटीज एंड डिफरेंसेस सीक्वेंसेस। इसके अंदर है कंक्लूजन। इसमें एग्जैक्ट मैचेस इंक्लूड कंप्लीट मैचिंग इन टर्म्स ऑफ रेसिड्यू एंड देयर ऑर्डर। ठीक है, इनएग्जैक्ट मैचिंग include partial inexact matching include partial matching in terms of residues and order with room for variations in both। ठीक है, ओके जनाब, ये हो गया डन। हम इसकी वर्क असेसमेंट ले लेते हैं अब। सही हो गया, इसी क्वेश्चन लेंगे सबसे कंसर्न एग्जैक्टली सिमिलर टू ईच अदर means they might have some level of pressure or cell system they integrate specific presence like nature of any protein or change। ये आप चलो चलो अगला टॉपिक की तरफ। हमारा अगला टॉपिक है टॉपिक नंबर 72 और पेयर वाइज सीक्वेंस अलाइनमेंट। ठीक है, फिर हम इसको कर लेते हैं क्वेश्चन ले लेते हैं। सबसे पहले तो चलते हैं आगे। सीक्वेंस अलाइनमेंट हेल्प साइंटिस्ट इंटरफेयर द फंक्शन ऑफ म्यूटेशन सेल जीन स्ट्रेस आउट द इवोल्यूशनरी रिलेशनशिप प्रेडिक्ट न्यू मेंबर्स ऑफ जीन फैमिली। लेट्स सी, यप चलते हैं आगे। अल्हम्दुलिल्लाह ये भी ठीक हो गया था और अब हम अपनी वीडियो सुन लेंगे। ठीक है,
Dear students, in this module, I'm going to introduce you to pairwise sequence alignment. This will be the first module in a series of 3 modules, and I'm going to introduce you to the concept of pairwise sequence alignment in this module. You already know that there are 2 types of matches when you're trying to compare 2 biological sequences. Exact matches are when you have 2 sequences and they're matching with each other amino acid by amino acid or nucleotide by nucleotide, and that they are in the exact same order. So in this way you can obtain an exact match. However, what if you have 2 sequences which do not have an exact match with each other? Which actually is the majority of the cases that you will encounter. In such a case, you can employ inexact matching, and in inexact matching, you can consider variations, differences between the sequences. Let's take a look at the pro-site patterns again. So pro-site patterns, they allow you to build templates for inexact match. So let's take a look at this pattern again. So this is from your textbook, chapter 3, page 44. So these are the amino acids, as you already know now. While X represents any amino acid from the 20 amino acids. Essentially, when you have an X anywhere in the pro-site pattern, it means you can place any amino acid. I've circled all X's for you. Next, the bracketed numbers, they denote the repeat length of the residue. So for instance, here you had an X, right? So you can have any amino acid here, and that it should be repeated 10 times. So there are 10 amino acids that are here between F and R. In this way, you can fill up the area between these 2 amino acids. Next, there can be a case where this repeat length varies. As we just saw, in this case the repeat length was just 10. So you could have 10 amino acids that were repeated. Here, a little down in the sequence, you can see 72,86. So it essentially means any amino acid, because there is an X here, it can occur between 72 to 86 times between E and R. So this is how pro-site patterns are built, and that they are very useful in generalizing the patterns within the sequences. Just to remind you, this pro-site pattern is for the MAP kinase, which is a very, very important protein in the cellular life. So all the proteins in the SwissProt database which are of MAP kinase, they follow this pro-site pattern. Okay, so let's move on. So to introduce you to the topic of pairwise sequence alignment, you need to identify conserved sequences or unchanged sequences or amino acids within the overall sequence. To begin with, you need to check for each amino acid in the corresponding sequence and see if there is a change or they are conserved. So this process involves inexact matching or considering mismatches while matching the overall sequence. Therefore, this process is called alignment. So you have 2 sequences that align against each other, and you're doing it in an inexact way, therefore accommodating certain differences within the sequences. So pairwise would mean you have 2 sequences which you're trying to compare. So pairwise sequence alignment will be sequence alignment between 2 sequences. 2 examples are given here for you. So as you can see in the first example, this is sequence 1, this is sequence 2. So this is a pairwise alignment, and that all amino acids, they match each other very nicely. So you similarity between these two sequences. However, in the example given below, you can see that everything is matching except this portion. So because these two amino acids could not be found in the upper sequence, so we have represented them with two dots here. The rest of the sequence matches very nicely. So these dots are called gaps, and we'll talk about them in detail later. So in conclusion, the pairwise sequence alignment allows you to compare two sequences against each other, and that it is an inexact matching process. And lastly, as you just saw in the second example of the alignment, if some amino acids or nucleotides are not present in the other sequence, then you represent them by placing a dot, and this is called a gap.
सो फ्रेंड्स, हमारी हो गई है वीडियो और अब हम चलते हैं अपनी रीडिंग की तरफ। ठीक है जनाब, चलते हैं रीडिंग की तरफ, रीडिंग कर लेते हैं। सही, बैकग्राउंड सीक्वेंस अलाइनमेंट इज अ वे ऑफ arranging the sequences of DNA, RNA or proteins to identify regions of similarity that may be a consequence of functional, structural or evolutionary relationships between the sequences. Pairwise sequence alignment is used to identify regions of similarity that may indicate structural and or evolutionary relationships between two biological sequences, protein or nucleic acid. Pairwise sequence alignment methods are used to find the best matching piecewise local or global alignments of two query sequences. Pairwise alignment can only be used between two sequences at a time, but they are efficient to calculate and are often used for methods that do not require extreme precision. ठीक है, उसके अलावा हमारे पास है such as searching a database for sequences with high similarity to a query. ठीक है, the three primary methods of producing pairwise alignment are dot matrix methods. So here dynamic programming, database for sequences with high similarity to a query. The three primary methods of producing pairwise alignments are dot matrix methods, dynamic programming, for example. ठीक है, so here उसके बाद हम चलते हैं आगे। And word methods. However, multiple sequence alignment techniques can also align pairs of sequences, although each method has its individual strengths and weaknesses. All three pairwise methods have difficulty with the highly repetitive sequences of low information content, especially where the number of repetitions differ. The two sequences to be aligned, exact matches mean all nucleotides or amino acids are same, whereas inexact matches mean there is some or more difference between the sequences in form of change in nucleotides or amino acids. Introduction: before the matching of nucleotide or amino acid, we determine that conserved residue, a residue which is exactly same in sequences known as conserved residue. If सबसे पहले सही हो गया इसका कोई लड़का सीक्वेंस अलाइनमेंट चाइल्ड सेंटर्स कोर्स एवरीथिंग वीडियो सुन लेते हैं
Dear students, in this module we're going to continue exploring the pairwise sequence alignment. This is the second module in the series of 3 modules on pairwise sequence alignment. Let's take a look at what we already know. So pairwise sequence alignment essentially means that you're trying to compare two sequences. And the process that it involves is the inexact matching process. In the inexact matching process, we consider some differences between the sequences, and if there is an insertion or a deletion within the two sequences, then we can create a dot in the alignment, and this is called a gap. So the process that you need to remember always is that the process starts with sliding the two sequences against each other. So once you do that, then you try to maximize the matches between these two sequences. And thirdly, during this maximization of the matches, if there is a situation where there is an extra amino acid or nucleotide in one sequence, then in the corresponding sequence you place a dot. This is called a gap. Let's talk about the gaps. Gaps are very important because in the evolutionary process, sometimes a nucleotide or an amino acid may be inserted into the sequence or deleted from the sequence. So in either case, if you arrive at a situation where you have to compare two sequences where one amino acid or nucleotide is missing versus another sequence in which that nucleotide or amino acid is present, then gaps are very useful and handy. So to introduce the gap, we must introduce a penalty as well, because if two sequences are matching with each other but there is a gap in the middle, then we need to penalize that gap, or we need to give a negative score to that match. If we do not give a negative score, then an exact match will obtain a score that is equal to an alignment where you have only one gap in the comparison of the two sequences. Therefore, gaps need to be given a negative score whenever you're aligning two sequences. Now let's take a look at the types of pairwise sequence alignment. There are two types in general. One is the global and the other is the local pairwise alignment. So in the global pairwise alignment, your aim is to maximize the sequence matches over the entire sequence by introducing gaps. So this is very, very important. I will repeat again. In the global pairwise sequence alignment, you try to maximize the sequence match over the entire sequence by introducing gaps. While in the local pairwise sequence alignment, you don't do that, and you only go for the strongest similarity within the sequence. It does not have to be the entire sequence in this case. So you're only matching the local portions within the sequence. While in the global pairwise sequence alignment, you're trying to compare the full sequences against each other. So therefore, for the global sequence alignment, you determine the overall similarity. While in the local pairwise sequence alignment, you only find similar domains or actually portions such as motifs between motifs and domains between two sequences. So in this way, local alignment helps you identify portions within the sequences which are very similar, while the global pairwise sequence alignment allows you to compare two sequences in their entirety. So as I just mentioned, the global alignment maximizes the number of matches between the query and the source. These are the two sequences along the entire length of the sequence, while the local alignment gives the score to the local map between the query and source sequence. There is a third category of sequence alignment as well, which is actually not a formal category, and that is the optimal alignment. So this kind of alignment exhibits the most correspondence between the query and the source. It is the alignment with the highest score. We'll discuss how to score these alignments later, so we will come back to the optimal alignment at that point. Important to note here is that such a highest scoring alignment may not be biologically meaningful. So in conclusion, the gaps are inserted to accommodate insertions and deletions of nucleotides or amino acids from sequences during the evolutionary process, and that global and local alignments are used depending on our objective for aligning the two sequences. If we are trying to compare the entire sequence versus another sequence, then we can use a global alignment, or if we're trying to compare only portions of one sequence in another sequence, we may go for local sequence alignment.
तो फ्रेंड्स हमारी वीडियो जो है कंप्लीट हो गई। हम चलते हैं अपनी रीडिंग की तरफ। There are two types of pairwise alignment: local and global alignments. Local alignment is an alignment of two subregions of a pair of sequences. This type of alignment is appropriate when aligning two segments of genomic DNA that may have local regions of similarity embedded in a background of a non-homologous sequence. Global alignment. A global alignment is a sequence alignment over the entire length of two or more nucleic acid or protein sequences. In global alignment, the sequences are assumed to be homologous along their entire length. Okay. Background. In pairwise sequence alignment, we align two sequences of nucleotides or amino acids. Matches are shown in colored form, whereas mismatches are denoted by dot. Salient points. Salient points. Sometimes sequences are slides on each other to maximizing the matches and mismatches, whereas gaps are used for deletion and insertions. Gaps are reducing overall score of alignments. Types of pairwise alignments. Mainly there are two types of pairwise alignments: global alignment, local alignment. ठीक है, उसके बाद global alignment, a type of alignment in which we introduce gaps for getting maximum matching score is known as global alignment. In this alignment, we align whole sequences. Local alignment, a type of alignment in which we find those regions which have strongest matching conservation. And local में है find regions between two sequences that have the strongest similarities, excluding less similar regions, finding similarity domains, similar domains, motifs, and detecting distant homology. Introduction to computational biology, an evolutionary approach by Bernhard Howbold, Thomas V. Mitogen activated protein kinases are protein kinases that are specific to the amino acids and serine, threonine, and tyrosine. MAPKs belong to the CMGC, CDK, MAPK, GSK3, CLK kinase group. MAPKs are involved in directing cellular responses to a diverse array of stimuli such as mitogens, osmotic stress, heat shock, and pro-inflammatory cytokinesis. ठीक है, they regulate cell functions including proliferation, gene expression, differentiation, mitosis, cell survival, and apoptosis. ठीक होगा. उसके बाद है global alignment. Maximizes the number of matches between the query and source sequences along the entire length of both the sequences. Local alignment gives the highest scoring local match between both query and sequences. Optimal alignment, one that exhibits the most correspondences between the query and the source sequences. ठीक है. इसके बाद है it is the alignment with the highest score, biologically meaningful. ठीक है. Introduction to computational biology, an evolutionary approach by Bernhard Howbold, Thomas V. Mitogen activated protein kinases, MAPK, are protein kinases that are specific to the amino acids serine, threonine, and tyrosine. MAPKs belong to the CMGC, CDK और MAPK और GSK3 और CLK kinase group. MAPKs are involved in directing cellular responses to a diverse array of stimuli such as mitogens, osmotic stress, heat shock, and pro-inflammatory cytokinesis. They regulate cell functions including proliferation, gene expression, differentiation, mitosis, cell survival, and apoptosis. Okay. Conclusion: gaps are inserted in a sequence being aligned to accommodate missing amino acids or nucleotides. Global and local alignment is used depending on the required type of pairwise alignment. ठीक है. ओके डन, हमारी रीडिंग ये टॉपिक हमारा हो गया अल्हम्दुलिल्लाह डन. हम चलते हैं अगले टॉपिक की तरफ, टॉपिक नंबर 74 और पेयरवाइज सीक्वेंस अलाइनमेंट 3. इसको क्विज ले लेते हैं हम लोग.
Maximize the number of matches between two sequences. Yeah? May be inserted to accommodate insertions or deletion, and we will look at them in detail by example in this model as well. So your objective is to maximize the number of matches between the source and the target. Okay. So let's review the three differences, the three sources of differences that can be there in biological sequences. So the sequences can differ from each other in three different ways. if there are substitutions, then essentially, as you can see here, C has been replaced by a G. So the sequence ACGA has become AGGA. This substitution is actually a mismatch because C does not match G. The rest of the three nucleotides, that is A, G, A, are matching very nicely. So there is only one difference between these two sequences, and this difference can be classified as a substitution. Next, let's take a look at insertion. So if you have a sequence ACGA and you're comparing it with another sequence ACCGA, then you can guess that there is an extra C here, and this is an insertion. So the two sequences will match very nicely, except for this C in the middle. This is an insertion. Now, let's take a look at deletions. In case of deletions, if you have a sequence ACGA and you're comparing it with another sequence AGA, you can clearly see that this C, cytosine, has been deleted from this sequence. So there are these three sources of variation that can be there in the sequence. So if there are no chain between nucleotides, for instance, A matches A, then it's classified as a match. However, if there are insertions or deletions, then we can create a gap. Let's see. A, C, D, A will actually be compared with this sequence AC dot this dot will mean that there is an insertion that has happened. Let me clearly write that again for you. If you're looking at this sequence versus this sequence, let me write the bigger sequence on top. Then you can see our dot here. This is a gap. The third option that you can have is the substitution, which will result in a mismatch. This was shown to you in the first example. We have A, C, D, A versus A, B, D, A. It will result in a mismatch in C and G. So these are the variations that you need to consider while aligning sequences. And now I'll come to optimal alignment. So let me give you an example. What an optimal alignment is. So let's consider a sequence. This is a rather longer sentence than the next. The second sequence is this is a short sentence. So if we try to align these two sequences, then we have two possibilities as an alignment. In the first one, it will start like this R, it will be a perfect match. Then O will match with an O, the sentence will match with the sentence. For the rest, you can insert the gap dot. Of course, if you look carefully, then there are a couple of mismatches as well, S, A, R. In the second case, the two alignments were the same. versus all them, and a few mismatches as well. So if I were to ask you which alignment is better, this one or this one, what will be your answer? So it actually depends. In my opinion, this alignment makes more sense, while this alignment does not make a lot of sense if you are looking at the English language. But for the biological sequences, this may just be more meaningful. So we'll be studying this in the later modules as well in detail. Before we go on, please do not forget that the biological context is very important to decide the answer to this question about which alignment was better in this case. So in conclusion, the global and local pairwise alignments, they help you to compare either the entire sequences or portions within the sequences in an exact fashion. Indels lead to gaps in the alignments, whilst substitutions may lead to mismatch.
So फ्रेंड्स हमारी वीडियो कंप्लीट हो गई है. सुबह चलते हैं हम लोग अपनी रीडिंग की तरफ. सो लेट्स मूव ऑन. रीडिंग कर लेते हैं. If two sequences in an alignment share a common ancestor, mismatches can be interrupted as point mutations and gaps as indels. That is insertion or deletion mutations. सही है. Introduction in one or both lineages in the time since they diverged from one another in sequence alignments of proteins. The degree of similarity between amino acids occupying a particular position in the sequence can be interpreted as a rough measure of how conserved a particular region or sequence motif is among lineages. The absence of substitutions or the presence of only very conservative substitutions, that is the substitution of amino acids whose side chains have similar biochemical properties in a particular region of the sequence, suggests that this region has structural or functional importance. Although DNA and RNA nucleotide bases are more similar to each other, so then are amino acids. The conservation of base pairs can indicate a similar functional or structural role. उसके बाद है to compare two or more sequences, it is necessary to align the conserved and unconserved residues across all the sequences. Identification of locations of insertions and deletions that have occurred since the divergence of a common ancestor. These residues form a pattern from which the relationship between sequences can be determined with phylogenetic programs. When the sequences are aligned, it is possible to identify locations of insertions or deletions since their divergence from their common ancestor. There are three possibilities. The basis match. This means that there is no change since their divergence. The basis mismatch. This means that there is a substitution since their divergence. There is a base in one sequence, no base in the other. There is an insertion or a deletion since their divergence. सर ने बहुत अच्छा वाला समझा दिया, अच्छा by applying all the above ways to any sequence to any sequence of matching and mismatching can be increased or decreased between two different comparing sequences. Match, no change between or among sequences. Mismatch, substitutions in sequences. ठीक हो गया, सही. So gap, insertion or deletions in sequences. Optimal alignment. The optimal alignment of two protein sequences is the alignment that maximizes the sum of pair scores less any penalty for introduced gaps. ठीक है. इसके बाद given below is the example to study the concept of optimal alignment sequence 1 and 2. This is a rather longer sentence than next. This is a short sentence. ठीक है. इसको हम फिर अलाइन कर दिया दो तरीक़ों से, और बायोलॉजिकली फिट ये तरीका है, बट जो इंग्लिश के पॉइंट ऑफ व्यू से करें तो ये तरीका बेटर है. ऑप्टिमल अलाइंड सीक्वेंसेस. फर्स्ट वन बिकॉज देर आर 16 मैचेस एंड इन सेकंड सीक्वेंस देर आर ओनली 14 मैचेस. और ऑप्टिमल अलाइन जो है वो ऑप्टिमल अलाइन जिसमें ज़्यादा से ज़्यादा मैच कर रहे हो, तो बायोलॉजिकली ये वाला करेक्ट है. ठीक है. उसके बाद ये वाला इससे कम अहमियत रखता है क्योंकि ये 14 मैचेस है, जिससे ज़्यादा मैचेस है वो बेहतर है. सर इसके बाद है कंक्लूजन. कंक्लूजन में बहुत लोकल एंड ग्लोबल अलाइनमेंट्स गिव अस डिफरेंट रिजल्ट्स. इंसर्शन डिलीशन गिव्स gaps in alignment whereas substitution increases mismatch of sequence. Okay, so must go for our PPTs. अब हम PPTs की तरफ चलते हैं और उनको भी पढ़ लेते हैं और फिर हमारा टॉपिक हो जाएगा इंशाल्लाह डन. ठीक है. तो सीक्वेंस एनालिसिस, इसके अंदर है पेयर वाइज सीक्वेंस अलाइनमेंट 243. ठीक है. उसके बाद है बैकग्राउंड गिवन अ पेयर ऑफ सीक्वेंसेस strings of characters. Pairwise alignment tells the similarity between the sequences by maximizing the message. ठीक है. Sequences can differ from each other in three different ways. Substitutions ACGA, insertions ACCGA और deletions ACGA. No change, match, insertion or deletion indels results in gaps in alignments और substitutions results in mismatches. ठीक है. और ये सारा का सारा सेम है, हमने पहले भी पढ़ा है. ओके चलते हैं. पेयर वाइज सीक्वेंस अलाइनमेंट 3, ऑप्टिमल अलाइनमेंट लाइन 1 एंड 2. इन दोनों को हमने अलाइन करा. ठीक है. तो दिस इज rather longer sentence than the next. इसको इस सीक्वेंस में अलाइन किया करेंगे तो ये ज़्यादा अच्छे से मैच हो रहा है. Which alignment is optimal
students, in this module I'm going to introduce you to the topics of similarity and identity. Why do we need to study these topics? If you may remember, we're trying to compare two biological sequences. By biological sequences, I mean either a set of DNA sequences or RNA sequences or protein sequences. So when you're trying to compare two sequences from any one of these types, then you would want to evaluate. You want to check how good is the comparison between the sequences. Towards that, we need to know what is similarity and what is identity. To begin with, I'll talk about identity or sequence identity as it is called. Sequence identity is the number of nucleotides in case of DNA or RNA or amino acids in case of proteins, which may match exactly between two sequences. If we match 10 nucleotides from a DNA or an RNA sample with another 10 nucleotides in another DNA or RNA sample, then we can count how many nucleotides are there in each one. We can also look at which types of nucleotides are there in each one of these molecules, and we can also look at their arrangement. So let's take a look at an example. Here you have two nucleotide sequences, CAT-GCET. So I have numbered this to be sequence number 1 here, and CAT-GC. That is sequence number 2. So I would like to compare these two sequences and evaluate their similarity. So how can I proceed? The first thing that I need to do is I need to count how many matches exist between these two sequences. So as you can obviously count, the first nucleotide C matches, the second nucleotide A also matches. Similarly, the next three nucleotides E, G and C, they also match. So in total, you have 5 nucleotides that are matching exactly between these two sequences. Next, I'll have to calculate which sequence has the smaller length. You can simply count the number of nucleotides in sequence number 1 and sequence number 2. In sequence number 1, you have 7 nucleotides here, and in the second sequence, you have 5 nucleotides. So you are supposed to pick up the smaller length. So obviously, you will select 5. Next, you need to apply this simple formula wherein identity equals to the number of matches, that is 5, divided by the smaller length. As you just saw, the smaller length was 5 because sequence number 1 had a length of 7. So you selected 5. So now you have 5 over 5, and you have to convert it into a percent. So therefore 5 into 5 over 5 is 1, and 1 into 100% is 100%. So if you want to talk about the identity of these two sequences, they are 100% identical. So the points to remember in this case: number 1, the gaps are not counted. So if you have a gap in the sequence, then that is not considered as a match. and that is left out. Second, identity measurement is always made on the shorter sequence. As we just saw in the previous example, the shorter sequence was 5 nucleotides long, so we need to consider 5 as the smaller one. These 2 points are very important while computing the identity between sequences. Next, similarity. So what is similarity? So similarity essentially is the result of matching and transforming one sequence to another by finding the smallest number of edit operations. So let's say if you had sequence 1 and sequence 2, then you would want to compare these 2 sequences by sliding them against each other such that the number of modifications you have to make in one of these sequences in order for the rest of the nucleotides to match, you have to do minimum number of deletions, insertions and substitutions. So this is what is called edit. So we will look at insertions, deletions and substitutions later, but what we need to remember is that you need to cater for them. So therefore, to compute sequence similarity, you need to first align the 2 sequences in order for you to obtain the gaps and mismatching. This can of course be done by using pairwise sequence alignments. So in conclusion, identity is the count of nucleotide or amino acid matches that are exactly matching between the 2 sequences, and the gaps are excluded from this exercise. Similarly, similarity is then a different measure in which you have to compare the 2 sequences after aligning them with each other.
So friends, हमारा कंप्लीट हो गया वीडियो, हम चलते हैं अपनी रीडिंग की तरफ। Versus similarity. Background: how to compare 2 biological sequences, how to measure the degree of match between sequences, 2 concepts, identity and similarity. Sequence identity. Identity is the number of nucleotides or amino acids which match exactly between 2 biological sequences. Sequence number 1 CATGC TAT, sequence number 2 CHTGC. Calculate the identity between the sequences 1 and 2. Okay, so number of matches 1, 2, 3, 4, 5. Smaller length इक्वल टू 100%। ठीक हो गया। नंबर ऑफ मैचेस कौन सा है? ये 5 अपॉन स्मॉलर लेंथ 5 इंटू 100, 1 इंटू 100 आ गया 100%। ठीक है। उसके बाद में वंस टू रिमेंबर गैप्स आर नॉट काउंटेड, आइडेंटिटी मेजरमेंट इज मेड ऑन द शॉर्टर ऑफ द टू सीक्वेंसेस and sequence similarity result of matching and transforming one sequence to the other by finding the smallest set of edit operations, insertions, deletions and substitutions। ठीक है। उसके बाद इसके अंदर है सी ए टी जी सी टी डॉट सी ए डॉट जी डॉट टी जी सी। ठीक है। कैन बी कैलकुलेटेड बाय पेयर वाइज सीक्वेंस अलाइनमेंट फॉर कंप्यूटिंग सिमिलरिटी बिटवीन सीक्वेंसेस। यू विल गेट टू फर्स्ट align the two sequences using pairwise sequence alignment। ठीक है। okay, let's move ahead। conclusion है हमारे पास में identity is the count of exact matches between two sequences, gaps are excluded, similarity is the comparison between sequences calculated by using alignment approach। ठीक है। so अब हम आगे चलते हैं और प्रोसेस में ले लेते हैं इसको, फटाफट से इसको ले लेते हैं। उसके बाद हाँ डायनामिक प्रोग्राम just the count of exact सो अलहमदिल्ला होगा डन। और उसके बाद हम चलते हैं अपने नए टॉपिक की तरफ। हमारा नया टॉपिक है टॉपिक नंबर 76 इंट्रोडक्शन टू मल्टीपल सीक्वेंस अलाइनमेंट। और इसको ले लेते हैं इसका, और यहाँ पर इसका कुछ है जनाब सी डॉट सी जी टी ए सी टी डी सीक्वेंस शोज आइडेंटिटी सिमिलरिटी
Dear students, in this module, I'm going to start working on multiple sequence alignment with you. You're already aware that we can do pairwise sequence alignment and compare two biological sequences and score them using PAM 120 or glossary 62 matrices, amongst others. So to start with multiple sequence alignment, the pairwise sequence alignment only considered two sequences. So one sequence was put on top and the second sequence was put on the bottom, and we try to compare the nucleotides or amino acid between the two sequences. For the multiple sequence alignment, the same problem is expanded to include 3 or more sequences. So the need for such a strategy may be that if you want to compare the multiple sequences, then this can be very useful. So in the pairwise sequence alignment, we had global as well as local sequence alignment, besides the repeated matches or the overlap hanging portions of the trailing portions. In the MSA or multiple sequence alignment, we have mostly global sequence alignment only. Here we have several sequences, 5 of them, that have been aligned. We call them a block. They have been aligned such that see closely that there are some mismatches or substitutions. There are some gaps as well here as well. And they are there in the sequence. But the 5 sequences are aligned very nicely. So this is what can be achieved by looking at the MSA or by strategy. So for the pairwise sequence alignment, we use the dynamic programming paradigm, in which we had this This helped us to compare two sequences. But imagine a case where you have to compare multiple sequences, and therefore you would have to perform dynamic programming or BP in multiple dimensions. So that will increase the computational cost of the dynamic programming to such a proportion that we will not be able to run the program. In case of MSA, typically we do dynamic programming for no more than 9 or 10 sequences. If you have a lot more sequences, then we move to progressive alignment strategies. So in conclusion, multiple sequence alignment can help you to compare more than 2, that is 3 or even more sequences together, and dynamic programming strategy may have to be abandoned in favor of progressive alignment to compare these multiple sequences in a small amount of time. Also, the software that is most commonly used and we will see in the later modules is the protocol for multiple sequence alignment.
So friends, अब हमारी जो है वीडियो कंप्लीट हो गई, हम अपनी रीडिंग की तरफ चलते हैं. Background. In pairwise sequence alignments, we use pairs of sequences to compare them and scoring matrices. This was used to score the sequence ranks. Pairwise alignment used for either local or global alignment. Introduction. In multiple sequence alignment, we compare multiple numbers of protein and DNA sequences to identify the matches and mismatches. Multiple sequence alignment is mostly used for global alignment. So you get multiple sequence alignment versus pairwise alignment. For pairwise alignment, we use dynamic programming, but for multiple alignment, it would be very expensive computationally. So solution for this is progressive alignment. Conclusion. Multiple sequence alignment can help us to align multiple sequences. For MSA, we can use progressive alignment, so we can use cluster ऑनलाइन सॉफ्टवेयर टूल. ठीक है, डन हो गया. उसके बाद हमारे पास इसके पे प्लीज पढ़ लेते हैं हम लोग. मल्टीपल सीक्वेंस अलाइनमेंट. Pairwise sequence alignment involved comparison, that is alignment of two sequences. Scoring matrices were used to score and rank the sequences. Introduction. Multiple sequence alignment involves comparison of 3 or more sequences. Pairwise alignment was either local or global. Multiple alignment is mostly global. और ये सारी की सारी block of multiply aligned sequences. ठीक है. For a pairwise alignment, we use dynamic programming. For multiple sequence alignment, we use dynamic programming. Maybe make it very expensive computationally. Solution is progressive alignment. Conclusion is multiple sequence alignment can help align multiple sequences. Dynamic programming cannot be used as it becomes expensive. Progressive alignment can help perform multiple sequence alignment. Cluster is the online tool. So अब हम चलते हैं अपनी पोस्ट असेसमेंट की तरफ और क्विज ले लेते हैं. और multiple sequence alignment is mostly global. True. The procedure of aligning many sequences is simultaneously is called फिर मल्टीपल सीक्वेंस अलाइनमेंट वाज आइदर लोकल और ग्लोबल, आइदर लोकल और ग्लोबल फॉल्स हो जाएगा क्योंकि ठीक है, क्योंकि है लीव ग्लोबल। सर इसकी वीडियो सुन लेते हैं।
Hey students, in this module we're going to continue on building our concept of multiple sequence alignment, or simply MSA. So the multiple sequence alignment, or MSA, simply put, helps us compare multiple biological sequences towards comparing them. Moreover, this comparison can help us to infer some very useful information regarding these sequences. For instance, you can find out consensus sequences between multiple sequences, that is, those portions within the sequence that are present in the other sequences as well and are very useful for some specific biological function. Moreover, the MSA can help you to construct the evolutionary relationship between these multiple sequences, as in which sequence evolved from which other sequence and which sequence is the oldest one and which sequence is the latest result from the evolutionary process. Such a study is called phylogenetics, or simply phylogeny. To apply MSA, you put multiple sequences against each other and you compare them, and this can help you to identify secondary, tertiary, or quaternary structures of the proteins as well. So this can be very useful if you want to study the protein function. This topic will be considered in the protein structure chapter. Moreover, as I just mentioned, phylogeny can be extracted from such sequence comparison as well, and this topic will also be dealt in the upcoming chapters. Towards the MSA methodology, or to understand how MSA works, if you remember, pairwise sequence alignment was simply a comparison between two biological sequences, or two nucleotide sequences, or two amino acid sequences. In MSA, you would want to do it for multiple such sequences. So therefore, you simply repeat the process of pairwise sequence alignment in a way that you end up aligning multiple sequences. So let's take a look at the process in detail in a step-by-step manner. So first of all, you find and list all the sequences to be compared, and this can be done by simply finding their ID. Next, you compare these sequences that you already listed, and you build pairwise alignments. So once you have performed pairwise alignments, then you move towards clustering. So clustering is essentially a strategy to make pairs of most similar sequences. That is, you perform clustering, you form pairs of sequences that are most similar to each other. In this way, if you have 4 sequences, for example, and you want to have a multiple sequence alignment, then 2 sequences that are closest will form the first pair, and the other sequences that are closer or similar to each other will form another pair. So this process is called clustering. So next, using this clustering information, you create a hierarchy using binary trees, or simply something like this. Next, you align the 2 best sequences and you keep them with you, and you repeat the process for the next pair of best aligned sequences. So essentially, if you have 2 sequences, 1 and 2, given by A and C here, and you have aligned both of them. And for the next B and D sequences, you have aligned them as well. So now you want to create an alignment between this pair and this pair. So you align the two pairs. Dear students, this is a very important point to remember. So in the first step, you have aligned sequences that are similar to each other, thereby creating pairs of sequences. And now you are aligning the pairs themselves. So in conclusion, multiple sequence alignment can help you compare multiple sequences in a go. And this process can help you to find out evolutionary relationship between sequences, also to predict secondary structures of proteins, and moreover to create phylogenetic trees as well. An important thing to remember in this regard is that you need to consider only those sequences that are divergent or different from each other by less than 80%. So if you have two sequences that are similar to each other more than 80%, then you don't want to do that, because this will create a bias towards these two sequences. And lastly, Clustol is a tool. It's an online software that can help you perform sequence alignment.
So friends, हमारी वीडियो हो गई, हम चलते हैं अपनी रीडिंग की तरफ। तो अपनी रीडिंग कर लेते हैं। ठीक है, बैकग्राउंड MSA helps us to compare several sequences by aligning them. MSA can extract consensus sequences from several aligned sequences, characterize protein families based on homologous regions. Application of MSA, ठीक है, multiple sequence alignment. There are many applications of multiple sequence alignment, but there are applications which are most important. We can predict secondary and tertiary structures of new protein sequences. We can also determine the evolutionary order of species or phylogeny. उसके बाद methodology. Pairwise alignment is the alignment of two sequences. MSA can perform by repeated applications of pairwise alignment. Find and list all sequences to be compared. Compare all sequences in a pairwise aligned manner. Perform clustering of pairwise aligned sequences. Create a hierarchy using binary trees. Alignment of two best aligned sequences is created. Process is repeated for next pair of best aligned sequences. Align most similar pair. Gaps to optimize alignment. Align next most similar pair. Alignments preserve gaps. New gap to optimum alignment of PD and AC. इन दोनों को वापस align करें। ठीक होगा। उसके बाद है conclusion. MSA can help us to align multiple sequences. Progressive alignment used for to perform MSA need to remove sequences with with less than 80% similarity. For this purpose, there are many online tools, but we will use cluster. सही है, यहाँ पर चलते हैं इसकी पेपर्स की तरफ। So more on multiple sequence alignment. Background: multiple sequence alignment helps compare several sequences by aligning them. Multi-sequence alignment can extract consensus sequences from several aligned sequences. Characterize protein families based on homologous regions. Application of MSA predict secondary and tertiary structures of new protein sequences. Evaluate evolutionary order of species or phylogeny. सही है। उसके बाद methodology. Pairwise alignment is the alignment of two sequences. MSA can be performed by repeated application of pairwise alignment. सही है। उसके बाद है more on binary tree. Animal sorry alignment of two best aligned sequences is created. Process is repeated for next pair of best aligned sequences. ठीक है, उसके बाद हमारे पास है align most similar pair. ठीक है, align next most similar pair, align alignments, preserve gaps, new gap to optimize alignment